citrate onwards, this is citric acid cycle. Yeah. But over here, this is not part of citric acid cycle. Here you need an enzyme called as pyruvate dehydrogenase plus 5 factors: thiamine, lipoic acid, coenzyme A, riboflavin FAD and NAD. So you've got 5 coenzymes, PDH plus 5 coenzymes. First one is thiamine in the form of thiamine pyrophosphate. So you can understand how important is this reaction. It is the backbone of your metabolism, because glucose enters the cell. This is the whole, this is the cell. This is cytoplasm. So glucose is converted to pyruvate in the cytoplasm. Then pyruvate goes inside through pyruvate transporter, and over here in the mitochondria, this is mitochondria. This is cytoplasm, this is mitochondria. And in the mitochondria, first of all, pyruvate is converted to acetyl-CoA. Is this a reaction of citric acid cycle? No. Pyruvate is converted to acetyl-CoA. Acetyl-CoA further, with the addition of oxaloacetate, is converted to citrate. These two get together, acetyl-CoA and oxaloacetate, and they get the formation of citrate. After the formation of citrate starts the citric acid cycle. Again, thiamine is taken in the diet, it's converted to the active form thiamine pyrophosphate. And thiamine pyrophosphate has a very important role in metabolism. How? Whatever we eat is converted to glucose. In the liver, we take glucose, it's as such, baki everything may be converted to glucose. Then glucose converted enters the cell under the influence of insulin or otherwise. It's converted to pyruvate, this glycolysis. Pyruvate enters for citric acid cycle, metabolism. And the first step is conversion of pyruvate to acetyl-CoA. Over here there are two things required. One is pyruvate dehydrogenase enzyme, and then there are 5 coenzymes. These two things are there. Pyruvate dehydrogenase and 5 coenzymes. Thiamine, lipoic acid, coenzyme A, FAD and NAD. So these are the 5 coenzymes which are formed. So if thiamine is not there, this reaction is blocked over here. And you can understand this reaction is so important. If it is blocked, the body will get very less energy and the patient will suffer from beriberi. Now, those people who are eating refined foods, burgers, or take boiled rice as a staple diet, as people in Southeast Asia, Bangladesh, etc., they are liable to suffer from deficiency of B1. Why? Because in white atta and polished rice, white rice, the outer covering has been removed. And when the outer covering is removed, B1 has also been removed from the diet. Thiamine is not there. And when thiamine is not there, how pyruvate will be converted to acetyl-CoA? That means pyruvate will not be converted to acetyl-CoA if there is no B1. Why? Because if there is no B1, that means thiamine is not there. So pyruvate dehydrogenase will not act on pyruvate and will not convert it into acetyl-CoA. If there is no acetyl-CoA, there will be no formation of citric acid, citrate. If there is no citrate formed, citric acid cycle cannot work. And so the amount of energy 30 ATPs, 30 ATPs, there is no citric acid cycle, there is no 30 ATPs. And the patient will suffer from what? Beriberi. Beriberi means I cannot. Beriberi means I cannot. Extreme weakness. And different forms of beriberi which will come later on. So now I would like to tell you the conversion of pyruvate to acetyl-CoA. So, remember this was the structure of B12. You've got the first reaction will be pyruvate. This is pyruvate, CH3CO. This is CH3CO, COOH. This is pyruvate. This is attached to this place because it is thiamine pyrophosphate. The enzyme I told you, it is pyruvate dehydrogenase. And the 5 coenzymes are thiamine, pyrophosphate, lipoic acid, coenzyme A, FAD, flavonoidin dinucleotide, and NAD. So these are the 5 coenzymes. So one is pyruvate dehydrogenase and the other is coenzymes. These are 5 coenzymes. 5. I mean pyrophosphate. So pyruvate attaches over here. And you get the formation of hydroxy ethyl thiamine pyrophosphate. This is step number 1. Then it attaches to lipoic acid. Forming acetyl lipoamide. The second step is acetyl lipoamide. This step is somewhat like this. CH3CO. This is step number 2. Number 3 is that it is attached to coenzyme A. That is called coenzyme A. It will lead to the formation of acetyl-CoA. That is CH3COSCOA. This is called as acetyl-CoA. This is step number 3. And it will also give rise to LSH. This will give rise to FAD will come, it will become as FADH2. Then this is the 4th step. Then NAD will come, NAD. It will become NADH2. This is step number 5. And this goes to biological oxidation. And this one gives rise to ATPs, energy, in the form of ATPs. I'll repeat again. We want this thing, pyruvate acid, to be converted to acetyl-CoA. This is thiamine pyrophosphate. So first it reacts over here to form hydroxyethylthiamine pyrophosphate. Then it reacts with oxidized lipoic acid. This is lipoic acid. Lipoic acid. This is in the oxidized form. When it reacts with this one, it forms acetyl lipoamide. Second step. Acetyl lipoamide plus coenzyme A will give rise to the formation of acetyl-CoA. Acetyl-CoA, and also it will form reduced lipoic acid. Reduced lipoic acid. Reduced lipoic acid is first acted upon by FADH2. FAD to form FADH2, then NAD to form NADH2, the 5th reaction. And this H2 reduced goes to biological oxidation in the mitochondria and releases energy in the form of ATP. So this is how ATP is released. So if there is no thiamine, there won't be any thiamine pyrophosphate, no acetyl lipoamide, nothing, no FADH2, no NADH2, and no energy. When there is no energy, the condition is called as beriberi, that is extreme weakness. I cannot. Patient will not do anything, will lose interest. Now, what are the deficiency symptoms? Let me tell you that. Beriberi is dry beriberi. Number 2, it is wet beriberi. Number 3, it is infantile beriberi. Well, then you've got some cardiomyopathy, cardiac involvement, cardiomyopathy involvement. And dry beriberi is a form of polyneuritis. Polyneuritis. The nerves are involved. The nerves are involved. In addition to that, you've got Wernicke, Korsakoff, psychosis. In Wernicke, there is to and fro movement of eyeball, that is called as nystagmus. And in Korsakoff, there is psychotic derangement, mental ability is reduced. So in beriberi, it contains all these things. This is all beriberi. Beriberi contains all these things. 1, 2, 3 and 4. And the treatment is to give vitamin B1. And deficiency of vitamin B1 can be diagnosed by erythrocyte transketolase activity. Erythrocyte transketolase activity. So, to sum up the biochemical role, B1 has got the following biochemical role. It causes oxidative decarboxylation, that is conversion of pyruvic acid to acetyl-CoA. Number 2, it causes the conversion of alpha keto glutaryl-CoA to succinyl-CoA, alpha glutaric acid to succinyl-CoA. Third, it causes oxidative decarboxylation of branched chain amino acids, keto amino acids, that is valine, leucine and isoleucine. So it causes oxidative decarbonation. Second is it causes transketolase activity, where in the HMP shunt, या mono pentose monophosphate or pentose monophosphate shunt transketolase activity. That is ribose plus xylulose and erythrose plus xylose activity. So 2 points, transketolase activity. And if there is no B1, there will not be any oxidative decarboxylation, and also there will be no transketolase activity. So this is B1. And B1 being so important, remember, for the conversion of pyruvate to acetyl-CoA, it is the only reaction in the body which needs 4 vitamins. One is thiamine, then another is coenzyme A, vitamin B5, riboflavin, FADH2, that is vitamin B2, and NAD, that is vitamin B3. So 4 vitamins plus 1 lipoic acid in the conversion of pyruvic acid to acetyl-CoA, and also alpha-ketoglutarate acid to succinyl-CoA. So you've got T, L, A, F, N, both ways over here as well over here. And also the enzymes are dehydrogenase. It's alpha-ketoglutarate dehydrogenase, this is pyruvate dehydrogenase. So these dehydrogenases don't work, and also the transketolase activity will not work. So B1 is very important, the central part of your metabolism. Central part of your metabolism. And HMP is so important because it is the HMP which gave rise to the formation of ribose. Ribose. And you know ribose is a component of your RNA and DNA. Because ribose is converted to deoxyribose in DNA. And ribose itself is a component of RNA. So if this is not there, this thing, whole thing will be stopped. And beriberi. I cannot work. Extreme weakness. So this was about B1. Also you must have seen those pigeons who are not given bajra, they are given white rice, तो कुछ देर के बाद उसमें उसकी neck retraction होती है. There is some defect with the nerves, and this condition in the pigeons is called as opisthotonus. Opisthotonus. O-P-I-S, opisthotonus. So there are 2 defects. One is beriberi and opisthotonus in the pigeons.